Hi, future doctors. Welcome to the next class. So, in this class, we will discuss about resistance, how it is going to be varying. Already we have discussed in previous class. R is equal to rho L by A. If length of the conductor is going to double, what happens to resistance? So at the time we said R is directly proportional to L square because volume we made constant. R is inversely proportional to A square and R is inversely proportional to R power 4. If length of the wire is going to be double, then what happens to resistance means, see here, R is directly proportional to L square. Therefore, it is double means resistance will become 4 times. And the percentage change in resistance, delta R by R into 100 is equal to 2 into delta L by L into 100. If percentage change is less than 5%, we will use this formula. If percentage change is greater than 5%, then we will use R1 by R2 equal to L1 square by L2 square. Just we will do one simple problem, you will get idea. So length of the wire is going to be stretched by 2%. Then what happens to percentage change in resistance? Then we have to use this formula. Percentage change in resistance delta R by R into 100 equal to 2 times of 2%. That is going to be 4%. Isn't it? So area of cross section. Area of cross section increases 2%. Then what happens to percentage change in resistance? So delta R by R into 100 equal to A power how much is the area? 2. Therefore, 2 into delta A by A into 100. So this is also 2 into 2%, but 4%. If area increases, percentage change in resistance decreases. Same like the radius. Radius means what we will take? So delta R by R into 100 is equal to 2 into, 4 into, because power 4 is there, 4 into delta R by R into 100. So percentage change in radius is going to be 2%, then it is going to be 8%. If it is increases, percentage change will decrease. This is less than 5% we discussed. Let us assume same question they asked, length of the wire increases 10%. Length of the wire increases 10%. Then I told you to take whenever it is greater than 5%, you can take initial values 100. R1 is 100, L1 is 100. This is best method, easy method. We will get very fastly. R2, we should calculate L2. So initial length 100 we have taken, 10% increase. Therefore, we will take 1. So if you apply this formula, R1 by R2 is equal to L1 square by L2 square. What is R1 here? 100 by R2 is equal to what is L1? 100 square by 1 times. This one only we discussed in our first video when we started our channel, directly proportional, inversely proportional. So A is directly proportional to the basics we discussed. 100 is cancelled. Then 1 by R2 is equal to 100 by 110 into 110. So 2 zeros cancel means 11 11s are R2 value, 11 11s are 120. So 121 means initial R1 how much we have taken? 100. Now how much increased? 21%. So now resistance increases 21% if length increases 10%. Like this we have to solve the problem very easily. Next, this resistance equation R is equal to rho L by A. So from this we will get rho is equal to RA by L. So what they will ask means, if length of the wire is doubled, area of cross section is 1/4, what happens to resistivity they will. So here resistivity depends on nature of material and temperature, but it does not depend on dimensions. Therefore, resistivity is going to be constant. Only resistance changes, but resistivity remains constant. If we are taking 1 meter iron wire, if we are taking 100 meters iron wire, so both the wires will have same resistivity, but resistance is different. So it does not depend on dimensions. So if it is iron tube, iron plate, iron wire, all these are having same resistivity. Understood? Now, mass of the wire is double, they will ask. Mass of the wire is double, what happens to resistance? Now, we should get relation between resistance and mass. For that, what we will get means R is equal to rho L by A. The two equations you will get if you keep volume constant, multiply and divide with area, then rho V by A square. Already we discussed this. Like that, another one you will get. Directly can I write? Rho L square by V. Did you remember this? In previous class we discussed. From there only you will get R is directly proportional to L square, R is inversely proportional to A square. Now they ask mass of the wire is double. So mass of the wire is double means we have to take density. D is equal to mass by volume. So volume is equal to mass by density. In place of this volume, you can write mass by density. Then you will get rho by A square into mass by density. So rho is constant, density is constant, so mass and area. Therefore, resistance is directly proportional to mass by A square. Same like this if you solve here. Rho L square, in place of volume, what we can write? M by D. M by D. Rho is constant, D is constant. Now in this case, L square by M. So mass term will be coming in numerator if area is in denominator. So already we came to know how to remember these equations. Already we came to know R is directly proportional to L square, R is directly proportional to A square. Therefore, you have to write M means here numerator is empty, here denominator is empty. So if mass of the wire is doubled by keeping its length constant, then R is inversely proportional to M if length is constant. If mass of the wire is doubled by keeping area constant, R is directly proportional to M if area is constant. So they will mention this in question. By keeping length constant, mass is double means resistance is going to half, isn't it? By keeping area constant, mass of the wire is double means resistance also double. So in this case it is directly proportional. In this case it is inversely proportional. They may ask graph also. What is the nature of the graph drawn between resistance and mass of the wire if length is constant? So what is the nature here? Inversely proportional. Therefore, rectangular hyperbola. In case of area constant means it is directly proportional, like this. So this is how resistance and mass depends. I hope you people understood. So problems you can do very easily once you know these relations. So we will meet next week. Thank you.